Hi, welcome. Welcome to listen to Erlab 10-minute short lecture. This lecture is about containment, the secret of your safety when handling chemicals. When we talk about handling chemicals in the laboratory, we need to introduce the concept of PEL-TWA, which is stand for permissible exposure limits, time-weighted average. In the simple terms, basically it actually provide the maximum exposure limits for any chemicals within 8 hours working time. For instance, in Malaysia, we have Use Regulations 2000. Use Regulations stand for Use and Standards of Exposure of Chemicals Hazardous to Health. In these specific regulations under DOSH, it actually specifies in Schedule 1 the ceiling limits or the maximum chemical exposure limits for any workers within 8 hours working day. So it actually specifies the PEL-TWA for every chemicals. Similarly, with the PEL-TWA value published in USA by the NIOSH, National Institute for Occupational Safety and Health. This is a compulsory for any workplace to protect the worker from hazardous chemicals. Example of PEL-TWA, they are very much from chemicals to chemicals, and they are expressed for liquids in ppm, for powder in milligram per cubic meter. Chemicals with high toxicity, for example, formaldehyde, has a PEL-TWA of 0.3 ppm part per million. Basically means within 8 hours, a person cannot expose to more than 0.3 ppm of formaldehyde. Chemical with average toxicity, example, this carbon tetrachloride, the PEL-TWA level is 5 ppm. Chemical with low toxicity like methanol, the PEL-TWA is around 200 ppm. So from this list, you can see that the lower the PEL-TWA of a chemical, the higher its toxicity level. Whereas the higher the PEL-TWA, the lower the toxicity level. PEL-TWA is published separately for each individual chemicals. You can find this information from the SGS safety data sheets, especially in section number 8. But in reality, laboratory handle more than one chemicals simultaneously. So when you mix more than one chemicals together, no one knows the health impact of this mixture, but one thing is for sure, it is danger. So what is the PEL-TWA of a mixture of chemicals? We can conclude this way. For any chemist has a responsibility to know the PEL-TWA for the chemicals that they are using. So the concentration of a chemical in the laboratory should be as low as possible in relations to the PEL-TWA. At 0 ppm possibly, maximum 1% of the PEL-TWA. To answer the questions of what is the PEL-TWA of a mixture of chemicals, so the answer is not more than 1% of the total PEL-TWA. So the long-term risk of a chemist should not be underestimated. The studies by OSHA stated that the life expectancy of a chemist in USA is at least 10 years shorter. Then the studies in American medical associations provide us this information. It's very worrying. In USA, 16% of the pregnant female chemists have problems with their babies. So we need to look into the safety of our lab operators. When handling chemicals in the laboratory, how to guarantee that the chemist is exposed to less than 1% of the total PEL-TWA of each of the chemicals that they are using. So before that, we have to know the rule of gaseous hazardous chemicals. The best way is to contain it in an enclosure. Why? Because according to the Graham law, air molecules collide with hazardous gas molecules and is distributed at a very high speed throughout the laboratory air. You can see from this graphic. Hazardous gas molecules travel very fast in the lab. In a fraction of a second, a molecule travels several meters away from its source depending on its weight. The lower the molecular weight, the higher the speed of transfer. Same as the perfume smell, which is also a solvent, which can be detected far away from its source. That shows how fast the molecule can travel. In order to stop these chemical molecules from spreading, it is crucial to perform the chemical experiments in an enclosure, which is a box, to contain it. The purpose is to contain the chemicals and to avoid them to diffuse. So we can say that no enclosure equals to no containment, and no containment equals to no safety at all. So basically, canopy hoods and suction arms have no enclosure, and they can't stop chemical molecules from traveling. They may have other usage, for example, for furnace and etc., but it's not for liquid chemicals and gases. It's not recommended. You can't be well protected when handling liquid chemicals under a suction arm, since it can't contain properly the chemical evaporations. Therefore, fume hoods with enclosure and ventilations have potentially the capability to stop molecules from traveling and to protect the chemist, since they can contain the hazardous chemical evaporation before eliminating it by ventilation system. How the containment of vented fume hoods been verified? Worldwide, there are standards like XRAIL 110/2016, like EU EN 14175, and China standards. They stated that the test method of the tracer gas SF6. Basically, they create emissions of the tracer gas and then measure at the nose level of the dummy outside of that fume hoods. This is examples of the containment test for fume hoods. Basically, they emit SF6 gas inside the enclosure with a speed of 4 liters per minute. They use SF6 because this is a synthetic gas. It's very light, so it's suitable to challenge the containments of that fume hood. The measurement is done at the nose level of a dummy for SF6 gas. So in order to pass the containment test, the measurements, the detections of the SF6 should not be more than 0.05 ppm. This is to ensure the fume hood will be able to contain the chemicals. Then we'll ask why we need to verify containment. Is this important? Yes. Containment will allow the fume hood to protect us even in a situation where there's a movement, where there's a slightly change in the pressure in the room, like when the door is open and closed, or even the air conditioning system. So the chemist will be always safe when they handle chemicals in the fume hood. Is this the first time you learn about containment? Remember, this is the key of your safety when you handle chemicals in your lab. Thank you for listening to this lecture. Contact us for more information and visit our website at www.tms-lab.com.